Hello, brothers. Long time no update. Yeah, because it's been a little busy these days, right? Okay, because at the beginning we explained. Initialization tutorial for customized We will talk about a section in this issue. Firmware interrupt tutorial. Okay. Or take our 811 network interface card as an example. What about the firmware? Firmware interrupts are divided into three types. Tradition. Another is this MSI interrupt. This is the address message address of MSI. The data sent here. Look at this network interface card. 81 network interface card is generally used MSI bar fork interrupt. Right? This is the MSI extension. The extended message signal is interrupted. This time we're going to talk about this MSI interruption. Right? Take this network interface card as an example. So when we make this MSI interrupt, you need to fork this MSI bar module. Delete it. Okay? We delete it all in the configuration space. That's it, right? We import the configuration space. I finished importing it. Let's import the configuration space. In this IP, okay, we have already imported this configuration space. We have deleted the MSI bar fork. Okay. Configuration space, right? 008170005. Corresponding. Right? Actually, implement this in the IP box. No need to modify 0081. Because why did we change it to 008107005? In fact, we can set it up in the IP core. You don't need to change it here. It doesn't matter if you don't because fill after in we fill in 081, it will be the last to die. Right? We can just die in the IP core. Right? We configure the space. But we put all MSI bars and forks have been deleted, right? Okay, I'll open ours. Open our. The file of the top layer core of the IP core, right? Inside this PCIe bar fork. Top level core file. Core file for the top level core. We have all changed 104. We are at the core. You need to implement MSI interruption here, right? We route according to our 8,188,168,811 network interface card to change the medium of MSI. MSIs. Interrupts are implemented in the core, right? Because the previous bits of our MSI are all 0. Our 64 supports writing to 64-bit addresses. This one didn't open. 0 is closed and 1 is open. It shows it's open. Then we have 60 for BIT here. We will change it to true. It means open. False means closed, right? We're going to open this too. The first thing we need to do in the IP core is to implement this. Right? And our dead wheel position. Let's wait a minute. Wait a minute. Use it in that CFG7 file, right? Open the message address here. These are driven by is automatically generated by the driver. There is also message data that is driven by. When you interrupt, you send a signal to the CPU, right? It automatically generates data, so leave it alone. So here we are in the dead man's seat. The MSI module needs to be opened. The module should also be open for it. Does 64 support 64? The 64-bit message signal should also be turned on. Others can be closed, right? The extended message signal also turns in the IP box, right? You must first implement it, right? Then we go. We'll find our endpoint logical CF bar in the VC file of the CF machine. Our endpoint logic. I have opened the CFGA7 file and it seems that. Okay. Our endpoint logic. In fact, this is his endpoint of 1337. His endpoint code. I just gave him a little adjustment. It's just that I gave him this. The code he broke, right? It's just that I adjusted it for him a little bit. The file I adjusted is here. Okay? You can go and find the source code. It's in the file code, right? We want, because of it, lock it out of this O bar and this signal. There are two on the front. We delete the signal for it. We can't block this input signal from him, okay? You can see our input. Block it for him. This is the difference from his code. And we deleted these three signals for him. What about these three MSI extended message signals? Three signals deleted it. Okay? First of all, the difference here. And our signal statement here. It's the same here, right? Signal statement here. But we put. In fact, it doesn't matter if this is deleted or not. But it's better to delete it. MSI bar X. I deleted the statement signal. Another difference is that, right? It's his. I crossed his MSI bar. The endpoint logic deleted him. Right? This is the one in front of you. I added a logic. The logic of the timer, right? I added a timer logic. And I added a timer logic, right? Because I want to. It won't count until 60 seconds. His interrupt triggers his interrupt, right? I added one. He is at 100 clock frequency. In the case of, and that happens pretty quickly. You see, I just added a timer logic. This kind of code, you can take a look at the code in this, right? According to his modification, right? Because he sent the middle section earlier. Here's the most important thing, right? Endpoint logic. After the endpoint logic of MSI is modified, we'll save it, right? We guarantee to save this CFG HSV file. And then we have to connect the instantiations. We also need to connect instantiations to other modules, right? In our HSV, in fact, these two statements can be ignored. The signal of these two statements. This is interrupting the dead man signal. Delete it first. Our strength. Because this HSV file is not needed here. No need to control this dead man signal. We put this. Interrupt the dead man signal 16 when connecting to the A7 module. Just set it to 1-to-1, right? Is dead. Interrupt the dead. Set it to 1-to-1 directly. Directly interrupt the dead. Then you also need to send this O bar also connect to CFG because we have this in this file. The top level module this one has this signal. Otherwise, it will go wrong. How many signals are connected to these two modules? Then we put it in the A7 file. How many signals must be connected, right? In fact, the signal of TIP is just connected. Top level file, right? Dead man signal set it to 1B1, okay. And we're done with that. We also set the MC interrupt for the IP core, right? Signal, all connected. Then we we're ready to build our project. Then we take 75T as an example. It's still an 811. Let's take 75T. We're ready to build our project because I have everything set up. I also wrote the endpoint code. And look at my face. So stuck. There are too many computer files in it. Let's talk about it again, by the way. We waste, by the way, our configuration space and Mustang. Mustang actually has a lot of tutorials online, right? Because if you want to have an ERF, you still have to write the strict code correctly, right? I wrote all this stuff in advance. Okay, this is still pretty simple. Okay, let's check again. And hidden inside the core. 9 MSI. Come here. Check it out, right? They're all open. The 64-bit message box is also open. Check our CFGA again. Check the signal. Check the logic. No problem. And there we go. Okay, let's fast forward. Because this generation is too slow. All right, let's pause for a second. Brothers, we think it's going to be ready, okay? Wait a minute. It'll be ready soon. Okay. We probably have it generated. Find the estimate we just generated. Copy it out from the firmware I just generated then.